So let's talk about the laboratory that's going to come up after the two that you have this week. This is a projectile motion laboratory. Again, you have the reference laboratory. Now, in the actual classroom, we use the vernier system. And the only difference between how I have you guys do it at home and how we do it in the laboratory is in the classroom, we use two photo gates to roll the ball off the edge of the table. You're going to have to come up with a marble, a ball, a golf ball, or something to roll off of your table. What we're going to do instead of using photo gates for that roll is we are going to use the video analysis software. So what you're going to do on your tabletop is you are going to take a ruler, and I would recommend a ruler that something like this, and you're going to use something to mark from the edge of the table, make a mark so that you can see 10 centimeters. So you know your distance. Velocity is distance over time. Then I recommend that you take a ruler, a channel of some sort, where you can consistently roll your object across the table, so you can do it the same way every time, to roll your object across that 10 centimeter mark. You'll use your video analysis software to record the time. You're going to need to do that at least 5 different times, because what you're going to come up with is an average velocity of your object rolling off the table. The object of the lab is to predict where the object is going to land on the ground. So in this lab, what you're going to do is you're going to use your video analysis software to calculate your velocity. And then you're going to predict where it lands off the edge of the table. And then you're going to compare how well that works. That's what you're going to do. And that lab is going to be due on June the 2nd. So you got 3 labs that have to kind of be done this week. Now I'm getting ready to go through this a little differently through my camera. So I'm going to stop my share. I'm going to Okay, so here on my table here, I will move my camera so that you can actually see. What I'm asking you to do is, here's the edge of my table. What you would do is you would come up with a couple of marks. You can do a piece of paper, you can use some masking tape, you can do something along those lines, and you're going to make a mark here to where you can see your 10 centimeters. Then you're going to roll your object building a ramp. So I can build a ramp this way. So I can use my ruler. If I'm using a marble, I can roll the marble down here, roll it off the table, and you'll focus your camera over the top and you'll be able to record that piece. You need to do it 5 times. Because what that's going to give you is our average velocity for that 10 centimeters. We know our change in distance is going to equal our 0.1 point meter. You're going to measure your time from your video analysis. You could even use your video analysis to determine velocity if you want to. But remember that my change in time, or my change in position over my change in time, is going to equal my velocity. And you're going to get at least 5 different velocities. So we're going to do this. We're going to do 1, 2, 3, 4, 5. And let's say it's 1.0 meters per second, and this is 1.1 meters per second, and this is 0.8 meters per second. This is 0.95 meters per second. And then this one is 1.05 meters per second. You'll calculate an average. So I'm going to take my 1.0 plus my 1.1 plus my 0.8 plus my 0.95 plus my 1.05. And I'm going to divide by 5. So let's do that real quick. Divide by 5 gives me my average velocity is 0.98. So what we have now for our experiment is, here's my tabletop. We're going to need to measure the distance between the tabletop to the floor. That's going to be h. When my ball comes off of the table, it has a velocity only in the x direction. The velocity only in the x direction. And we know it's going to end up going something like this. And this is the thing that we're going to predict. So you're going to do one more experiment. You're going to have it go over there. And you're going to figure out, you're actually going to measure this. And then you're going to compare your prediction. Well, how am I going to predict where it goes off? How am I going to do that? Well, a couple of things. I've got 2 equations, 2 unknowns. The other thing that we know is the velocity in the y direction at the beginning is 0. We have an acceleration due to gravity. That's 9.81 meters per second squared. So if I go over here, okay, I know that my change in height, so my change in height is going to equal 1/2 my acceleration due to gravity times time squared. Both of these are negative because my direction down is negative. So my change in height is equal to 1/2 gt squared. Time squared is 2h divided by g. So time is equal to the square root of 2h divided by g. My tabletop in my office, h is about 1.1 meters. In the physics lab, it's about 0.95 meters. Your tabletop might be something different, so you'll need that measurement. Now, you can do this in inches if you want, okay? Your rule, if let's say you have an old ruler, it's all in inches, you can do that, but to be consistent, you can do that and convert, or you can use G is 32 feet per second squared, if you want to do it that way. You can do it in inches and feet, if that's what you have. So I'm going to do this. I'm going to measure time. Time is equal to the square root of 2 times 1.1 meters divided by 9.81 meters per second squared. I'm going to calculate that time. I'm going to take the square root. And my time is 0.47 seconds. Well, now my prediction is distance is equal to velocity times time for the x direction. So if I measured my velocity, my average velocity was 0.98 meters per second. My time is 0.47 seconds. it should land about 0.46 meters away from the edge of the table. So this gives you a good estimate of where I'm supposed to be. That's where it should measure. So let's say I do it, and I measure it, and I go, okay, on my measurement, turns out that it was 0.50 meters. Well, that's not too bad. We can do a percent error, or we can do a percent difference. Percent error is the absolute value of the real minus measured divided by real times 100%. Percent difference is real, or measurement 1 minus measurement 2 divided by the average of the two measurements times 100%.
I can really see the top one.
Do what? Is that what you needed?
Oh, I see. Oh, yeah, there we go. That's better. Thank you.
Yeah. So let's do this. So my predicted, we're going to say, is the real. And so that one was 0.46 meters. My measurement is 0.50 meters. So my percent error for this experiment is going to equal 0.50 minus 0.46 divided by 0.46 times 100%. And I end up with 8.7% error. Now, in this lab, because we're going to do this 5 different ways, we actually can give ourselves a target. We actually can give ourselves a range, because we had a maximum of 1.1, and we had a minimum of 0.8. So given my 5 runs that I had, I could actually say what's the farthest away would equal the distance times my maximum velocity times my time. And that would equal 0.517, or approximately 0.52 meters. My closest to the table is going to be my 0.8 times my 0.47. And that would be 0.38 meters. So as long as my ball falls between 0.38 and 0.52, my experiments work pretty well. So we can actually play with the error and the error of the experiment on this one. So you can do a variety of different things when you're playing with the percent error, or actually doing your discussion of your ball. Particularly since in this particular one where we're taking the ball, we're rolling it down a ramp, we're allowing it to go off the edge of the table, to be absolute consistent between each one of those particular measurements, it's going to be a little difficult. So you will be able to do a little bit of an error analysis in this particular experiment. So hopefully that explains that experiment, that projectile motion experiment.